Hi everyone, welcome to today's tutorial, where we'll learn how to find the modular order of an integer in MATLAB. The congruence a raised to the power of x congruent to 1 modulo m is solvable if and only if the GCD of a and m is 1. The reason for this is that, by the Fermat-Euler theorem, if the GCD of a and m is 1, then a raised to the power of phi of m is congruent to 1 modulo m. That means there is at least one solution of the congruence, namely x equals phi of m. Here, a is an integer, m is a positive integer, and phi denotes the Euler's tocent function. So what exactly is the order of an integer? The smallest positive value of x that satisfies the congruence a raised to the power of x congruent to 1 modulo m is called the order of the integer a modulo m. Now let's look at an important theorem. Suppose the order of a modulo m is d, and there is an integer h such that a raised to the power of h is congruent to 1 modulo m. Then d divides h. From this theorem and Fermat's theorem, we know that d divides phi of m, meaning the order of a modulo m is one of the divisors of phi of m. Understanding this concept is crucial to finding the order. It's also important to note that a has an order modulo m only if the GCD of a and m is 1. Now let's break down the code step by step. In our previous tutorials, we created two user-defined functions, find divisors and Euler tocent. We'll use these functions in this program, so make sure you've watched those videos for a better understanding. The variable m stores the modulus and a stores the integer. We calculate the Euler's tocent function of m and store it in the variable 𝜙m. Next, we find the divisors of 𝜙m and store them in the array 𝗶𝗽𝗂𝗁. As mentioned earlier, a has an order modulo m only if the GCD of a and m is 1. So, we first check whether the GCD of a and m is 1. If it isn't, the error function throws an error and displays a message. Otherwise, we proceed to find the order. Since the order is one of the divisors of 𝜙m, we use a for loop to iterate through the elements of the array 𝗶𝗽𝗂𝗁. The index x takes on the value of these elements. PowerMod returns the modular exponentiation of a raised to the power of x modulo m. Using an if statement, we check whether the modular exponentiation equals 1 for any value of x in the array 𝗶𝗀𝗃. There may be multiple such values, but the first one we find is the smallest and represents the order of a modulo m. Once we find the smallest x, we store it in the variable order and use break to exit the loop. We terminate the for and if statements with the end keyword. Finally, we use fprintf to format and display the result on the screen. Now let's run the code for some values of m and a. Thanks for watching. If you enjoyed this tutorial, don't forget to like, share, and subscribe for more coding and math content. See you in the next video. This is Tough Nut, signing off. Happy coding.